Hello, good morning. So, the most important thing I will say today is that you have an F route in Poland. It was installed yesterday and brought live overnight, and that is the current traffic graph. So, uh, this is only peering traffic, although we have a transit link which we use for management. We only offer the F route prefix to peers at the PLIX, and so that tends to be only Polish traffic. And so I'm excited by this. It is one of the fastest starts we've ever had. And it's the route server that helps because we didn't have to start out by soliciting a lot of individual peering relationships. So for the rest of my time, I will tell you what this means, but this is the exciting part, so I thought I would begin with it. Oh. This one? Oh. So, I will talk to you a little bit about ISC, and I will tell you the two things, the F route and a security-related project that we are currently working on with Plex. It'll take a little less than an hour. I will be asking for some discussion and questions at the end, so I'm hoping this will be an interactive time slot. So this is about us. Do any of you remember the second largest computer company in the world in 1990? It was called Digital Equipment Corporation, DEC. That's a small number. They were bought by Compaq, who a lot of you also have not heard of, but they were bought by Hewlett-Packard. So the old empire is now part of HP, which is interesting for me. I worked at DEC from 1988 to 1993. And during that time, I took over the maintenance of some software called Bind because the Berkeley Unix team had disbanded. Now, when I left, it quickly became important that it was obvious to me that Bind should not stay with DEC. So I left DEC and took Bind with me. So if you look at some of the old Bind source code, you'll see that there are some DEC copyrights. And that just reflects where I was when I first began working on it. In the time since 1993, we have also produced a whole lot of Internet RFC documents to describe various protocols. DNS was at best unclear, but also very unfinished. And so I think ISC has been a technology leader in the DNS technology area. We rewrote Bind twice, once in 1996 and again in 2000. So the current version is Bind 9. It shares absolutely no code with the previous versions. It is the most popular name service implementation on the internet. We have about an 80% market share. The number 2 implementation on the internet is from Microsoft, and they give it away for free with other products that you buy from them, but it's still not very popular. Even people running Windows name servers tend to prefer Bind. We have begun work on Bind 10. That'll take about 5 years. We are at the end of the first year. It's another complete rewrite. I think you will all like it. Now, in addition to the protocol work with RFCs, and the implementation work with the source code, we operate some internet infrastructure, including F-route, but we also have a fairly significant regional network in the California area, in the San Francisco Bay Area. So we have dark fiber from San Jose to Palo Alto to San Francisco, and now including our home office in Redwood City. So it's perhaps 50 to 80 kilometer network of dark fiber. Might not seem significant to those of you who run big networks, but it's certainly a big network for a tiny little nonprofit like ours. We will be extending it to other parts of the world. We're going to head toward the east coast of the U.S. in the next few months, and hopefully add Amsterdam. Someday I hope to add Poland, but you know, we're doing this bit by bit. We don't actually have any revenue associated with our network. And as you might imagine, that makes it hard to pay for expansion. So we're currently 39 employees, and we're split across 6 different countries. We have 45 or so. I'm not sure if it's now 46, thanks to you, Froot instances, and our annual budget is about $6 million US, most of which comes from selling support contracts for Bind, sort of the traditional open source business model. So there are a couple of things we're doing in Poland. Since last year, we have been running a security information exchange relay node, and I'll explain that in the second part of this talk. And as of yesterday, we have Froot, which I am very impressed by. As I said, this is the fastest start we've ever had. I'd like to explain what Froot is and why you should be excited that you have one. There are 13 name servers at the root of the DNS hierarchy. They have names beginning with a single letter, so it's a.rootservers.net and then b.rootservers.net and so on. We used to have a more interesting name, ns.isc.org, but it was observed by Bill Manning sometime, maybe 1995 or so, that we could fit more name servers into the internet if we would give them shorter names with a common suffix. And so we all got single letter names. And so in the lottery, we received the letter F. Now the root zone is the parent of all top-level domains. So around here, the names I see most frequently on billboards or soda cans end in .pl. And yet none of the clients, none of the DNS clients or recursive name servers in Poland would have any ability to find the servers for .pl except by referring first to the root zone and asking, how do I find .pl? So one of the important jobs that is being done by Froot and by the other 12 name servers is to constantly tell people how to find a certain top-level domain. If the system worked better, then I expect that these answers would be cached. In other words, you might only have, let's say, 10,000 name servers, 10,000 recursive name servers in all of Poland. And so given that the information that's in the root zone doesn't change very often, you might think that we would get a total of 10,000 packets and we would refer all of them to the PL servers and we would see no more queries. It doesn't work that way because caching does not work the way it really should work. Most of the information that we that we answer with is quickly thrown away. In fact, many of the responses that we send back never reach the intended party. A lot of people ask us questions from behind a firewall, so we can hear the question, but they can't hear the answer, and so they sort of repeat it endlessly. We can't tell the difference. We have to answer it all. So I can tell you that Froot was once a single computer, and at that time the query load was very small, the internet was very small, it had not been commercialized. And then we had some DEC alphas, because of course I was at DEC at this time, and we realized early on that the equal cost multipath feature of OSPF would allow us to turn multiple servers on, and the router would handle our load balancing for us. I've always been attracted to simplicity. I didn't want to have a load balancing machine like an Alteon switch or any other load balancer because it was an additional power cord. And I've observed that tripping over a power cord is one of the frequent causes of outages. So if I had fewer power cords, I would trip over them less often. So the ability to do the load balancing in the router was very attractive to us. and in the time since then, we have expanded the footprint to include similar OSPF clusters in about 44 other cities, or possibly 45 other cities. I'm not sure of my exact counts here. So the reason that we do this Anycast is because of DDoS. If I was not concerned about a distributed denial of service attack, then a single froot cluster in one place would be enough to serve the internet. Now there are other side benefits, but DDoS is the most important thing. There's really no way to prevent a DDoS. I'm sure some of you have experienced this. When you're getting a lot of traffic and it's coming from 10,000 different captured PCs running some kind of malware, very difficult for you to make 10,000 phone calls asking 10,000 different people to stop sending you a few packets per second. So all you can really do when you're DDoSed is manage it, and to manage it requires that you have a lot more capacity than you would really need on a day-to-day basis. This is sort of an unfortunate requirement for every large provider of web services or anything else. I'm sure that Google and Amazon and people like that would be able to use a lot less electric power if they only had to provision for normal load. But since you have to have enough capacity for the worst case scenario, which is a denial of service attack, everything gets bigger and more expensive. So every froot Anycast node speaks BGP to some route server or to some collection of peers, and offers the same two prefixes, one for IPv4 and one for IPv6, using the same AS number. This makes it look, I suppose, as though froot was a single server somewhere with a particularly good wide area network that simply had backhaul to 45 cities and so forth. We don't. The backhaul would be prohibitively expensive. So what we really do is duplicate the BGP announcements that you would receive if we had one server with a large network. Instead, we have a lot of different servers that all offer the exact same service at the exact same IP addresses. So in addition to the DDoS benefits, what all of you will receive is a lower round-trip time. If you, and you will, as you and your customers contact froot, you will now be able to do so in a handful of milliseconds rather than a few dozen milliseconds or a few hundred, depending on where you were going before this. I suppose I should have done some traffic analysis to find out which froot you were talking to before today. The other big benefit, though, is that if, let's imagine there is a botnet that's centered in Korea, begins to DDoS us, the Korean Anycast instance will probably become unreachable. And so it will be service affecting in Korea, but it won't be service affecting here unless you have a lot of local Polish members of whatever botnet is attacking us that day. So there are some worst case benefits and also some everyday benefits. And then finally, in Poland, in Europe, you have an entity called RIPE that allocates IP address space. In the Americas, we have something called ARIN, A-R-I-N. I am the chairman of the board of trustees for ARIN, and I am keenly aware that we are about to run out of IPv4 space. I mean the whole world. IANA is about to, in the next year or two, will hand out the last bit of IPv4 that exists. And then the RIRs, like RIPE and ARIN, will gradually hand that out to folks like yourselves. And then there will be no more. So even though it has always looked like it would be a long time coming, long time in the future, for me, the IPv4 depletion problem is real. So we've been trying to push IPv6 for at least 5 years, maybe closer to 8 years. And froot is available by IPv6, and I'm urging all of you to investigate v6 if you haven't already done it. Figure out how you're going to provide dual stack to your customers. figure out how you're going to make sure that your services, if you have CDNs or web services, are available by IPv6. And one of the things you can do now that you have FROOT local to you is at least you'll be able to talk to us over IPv6, even if you can't really talk to most of the rest of the internet that way yet. So moving on from FROOT, let me tell you about a security project. So, time for a deep breath, changing gears, changing directions. To do any kind of security, whether it's installing locks on the door to this room or putting an alarm system in your car or doing putting passwords on your computer, you have to have some kind of awareness of what the threats are, not just the potential threats, but the actual threats. You have to know what's going on. In fact, one of the most powerful security devices that you will find is a camera, closed circuit television, as opposed to a lock, because knowing what's going on is actually more important than being able to control it in the grand scheme of security. But the internet is huge. It's so large that it has no specific definition. It changes as you are trying to define it. It will have changed its shape and its size and its extent and the density of connectivity and who's doing what. And as a result, there's no way to be generally aware of what's going on the internet. And this creates a real problem for internet security. The reason that we're being DDoSed by random botnets is because the internet is completely out of control. There's no way to know what it's doing or what's going on or what it will do next. That's why we get spammed. That's why we get phishing attacks. It's a big problem. Now, it's also a big opportunity. There are companies out there selling security services, products, whether it be an anti-spam filter or malware prevention filtering for your laptop, whatever. A lot of companies are able to make a lot of money because this is such a hard problem. And what these companies do in order to improve their own awareness so that they know where the threats are and what they should be protecting you from is that they operate private sensor networks. So they will install sensors, and some of you, I'm sure, have been approached by security companies who have said, gee, would you please put this rack mount server into your data center and plug it into a span port so that we can watch what's going on. This is a proven method. There are a lot of companies, as I said, making a lot of money in the security field by building private sensor networks and then processing the data from those sensors in a way that benefits them, benefits their customers. Now, the problem from my point of view is that this privately held information is always a subset. There's really no way that anybody can ever have a sensor network that is large enough that they really know what's going on and they really know pretty much everywhere at once what is going on. Now, we have a fairly broad charter at ISC. So we're a nonprofit company. We have no shareholders. We are incorporated in the public interest. So everything we do has to have some effect on the world that can be called positive. And we actually have auditors from the Internal Revenue Service who are willing to ask us the question, what have you done for the world lately? Now, within that broad charter, clearly we like to write software. That's where Bind came from. We like to write RFCs. We've improved DNS a lot. We like to operate things like FROOT. And those are our three big areas of historical expertise, which is software, protocols, and operations. But we've also had to build a business in order to fund ourselves. So we have pretty effective, in my opinion, sales operations. We can find new Bind support customers, and we can deliver services to them in a way that they will renew their contract. So with all those capabilities at our disposal, and with this big security problem lurking, which is the fact that all of the sensor networks on the internet today are privately held, we decided that we would dip our toe into security. We've had good luck so far. And I want to note that I myself was a founder at PAX. I'll be talking about that, I guess, a little bit tomorrow. I'm on the IX panel. We have probably a half dozen employees that used to work with me at PAX. I've brought them with me to ISC. We also have on our staff the founder of Links, the London Internet Exchange. So to me, security problems look a lot like Internet Exchange problems. And so when we wanted to build this, we built a security information exchange, and it was patterned very much after the Internet Exchange model. What I mean by that is that it's a private data center where members bring equipment. But whereas in an Internet Exchange, the equipment that people will bring tends to be a BGP-speaking router. In the case of our security exchange, they're bringing servers to analyze information. And what we're doing is broadcasting data into a private Ethernet switch that came from sensor networks. And we encourage our members to also broadcast information. Very few, excuse me, very few of them do, but we're seeing more of that. But the goal is to try to unify sensors so that everyone on the internet who is willing to instrument their network and share data can send us that data. We will share it in real time over a private Ethernet switch with a growing community of security analysts. So you'll hear us talk, if you actually listen to us about the Security Information Exchange, you'll hear us talk about channels, pretty much the way that digital satellite broadcast people will talk about channels. We use VLAN tags the way that digital satellite broadcast uses channel numbers. So you'll hear us talk about things like the passive DNS channel or the spam trap channel or something like that. All these are as VLANs, and each one has its own little subnet, and if you're plugged into the switch, you can decide which VLAN you'd like to be in and then start up some listeners on that channel. It's become a very useful model. No one has ever done this. No one has ever used VLANs the way we're using them. And we indeed do have a worldwide network of sensors. I don't have as many in Poland as I'd like to have, which is one of the reasons I'm giving this talk today. But we do have passive DNS sensors, a small piece of software that you can run either on the span port of one of your Ethernet switches, or you run it directly on a DNS server. I never collect personally identifiable information. I don't know your customers' IP addresses, and I don't know what they're seeing. I don't know what they're doing. The only thing I care about is if your recursive DNS server has a cache miss. Someone asks it for something that it doesn't know, and it has to go to the authority name servers and get a response. I want to see the response. And believe it or not, from just those responses, if you get them from enough different places, you can build an almost complete picture of what's going on the internet in real time. We also have net flow sensors, spam traps, link pairs, which means if you have some kind of a search engine that's building an index, we love to learn that this URL refers to that URL. And again, that sounds very simple, but if you get enough of that from enough places, you can build a very complete picture of what's happening on the internet. And no one has ever had a complete picture like that. It's not listed on this slide, but we also have a darknet channel. So if you have allocated address space that you're advertising in BGP, but you're not currently using, and it's receiving some kind of a consistent background radiation of people probing you, looking for open recursives or looking for Microsoft database servers or something that they can infect, we'd love to have that traffic. You're not going to answer it anyway, so you may as well give it to us. So we had to develop, we had to use all of every one of our skill areas. So we had to develop some new protocols to carry this information, new software to implement those protocols. First, I came up with something, and I admit I used to be a programmer, so sometimes I will make an excuse, even though I'm the president of ISC, and I should not be writing code. Sometimes I will make an excuse to write some code. and so it was in this case. PCAP files, which are the, I suppose, the common universal language of the security community, do not work for what we're trying to do, for a bunch of different reasons that I can talk about if there are questions. So we came up with NCAP as a replacement for PCAP. Turned out to be inadequate because it wouldn't hold spam trap data or link pair data and so forth. So we've replaced NCAP with NMessage about a year ago. And that's it's all open source software. The BSD license, it's completely reusable, it's completely embeddable in products and so forth. And what that means is, if you're willing to run a sensor for us, we probably have a tarball that you can download and configure very quickly and walk away from it. So one of the big things that's happening in the security community for the last year or so is a botnet called Conficker. I am a member of the Conficker working group core team, and one of my responsibilities is to coordinate these sinkholes. So raise your hand if you know what Conficker is and how it works. Oh my goodness. Okay. So in 2008, Microsoft published a vulnerability announcement, MS08-067, and they talked about a particular vulnerability in one of the RPC services that was enabled on every Microsoft laptop, every server, every desktop. And it was a simple buffer overflow, and if you sent it a particular packet with some of your code, it would execute that code in privileged mode. Now, this happens every couple of months. It's not big news when Microsoft does something like this. But what happened in this case is that somebody was ready with some very malicious code to go exercise that vulnerability. So they were pretty much had spent a long time developing a kit of software, and they were just waiting to be told what the infection vector should be. And this software is virulent. It will scan your network looking for other infectable machines. It will infect every USB key that goes into the machine. It will, it's nasty. So the result was that the Conficker botnet, the resulting botnet, quickly grew to over 1 million. In its first couple of months of operation, it grew to be over 1 million PCs in size. In the time since then, it has grown to 7 million. And I say again, I am a member of the Conficker working group, and we completely failed to do anything about it. There's nothing we could do. We've done everything we can to remediate it, and it just grows and grows. But the way that Conficker tries to contact its command and control servers is using DNS. It takes the current date, and it uses the date to calculate some domain names. And so every day it will look for up to 50,000 different domain names, and if it finds any addresses at those domain names, it will attempt to contact them looking for commands. So those domain names are split across 110 different top-level domains, and we have contacted the TLD operators, all 110 of them, to get them to delegate those names to us so that we can collect all of the web hits from all of the infected machines. This gives us the ability to at least estimate the population size. It also hopefully will lock out the bad guys from being able to register any of those domain names, because if they ever do, then they will have command of the largest botnet that anybody has ever heard of. So it's a big, latent global threat. But one of the things we're doing at SIE is to share the web hit information in real time on the Conficker channel, so that security analysts don't have to wait for the end of the day and then fetch from us log files to say, gee, where were the infected machines? We're actually able to share where the infected machines are pretty much in the same split second that they contact us. So it's the fastest response capability ever. Well, I want to say it has not stopped the worm from growing, but it has given certain security vendors the ability to notify their customers in real time that they appear to be infected. Because after all, if you contact one of our sinkholes, that's pretty much evidence that you are infected with the bad software. So it's been an interesting demonstration of SIE's capabilities, even though it hasn't done anything to shrink the population. And we also have, among our analysts, we have some who are members of SURBL, SURBL. It's a so-called RHSBL. It's a black hole list based on domain names rather than based on IP addresses. And now that they have the ability to see a lot of spam body URLs in real time, at the same time that they are collecting a whole lot of passive DNS data, they're able to cross-correlate so that when spam comes out advertising a certain product at a certain URL, they can find out all of the other domain names that use the same IP address or use the same name servers. And they can make some assumptions that if one is evil, they're probably all evil. And that in turn has allowed them to block bad domain names much more quickly than they could do before. And it, again, it relies on real-time cross-correlation, which has only been possible for security vendors with large sensor networks up until today. Now, we do have some other things besides the raw sensor data, because frankly, dealing with raw sensor data is hard. And we've discovered that a number of the people in the field simply cannot deal with high-speed binary data going by on a private Ethernet switch. On the other hand, we're keeping that raw data as our our flagship product, because we want to make sure that new kinds of analysis are possible. We want people to send us a computer, we'll plug it into our rack, we'll plug it into our switch, then they can write their own software and they can find new ways to use this data. That's, again, something that pretty much won't happen inside of security vendors, because once they have something that's working and producing a lot of revenue for them, they will stop improving it. Whereas we, since we're using Ethernet broadcasts that are very cheap because they're hardware enabled in the switches, we can add any number of new servers and new analysts without affecting the ability of the current analysts to keep on doing what they're doing. So, I thought I had one more slide in here. Looks like I don't. Oh, sorry, I mixed them up. So, what this means to you is that I'm hoping you will contact me, and say, gee, I think I might be willing to run a sensor. If you do, it'll be a fairly simple, very fast, very small piece of software that we'll ask you to run somewhere. Sylvester has provided a computer inside Plex that you can upload to, so you do not need to pay global bandwidth costs to send your data to us in California. Just send it to the local machine. And to the extent that it is legal for us to export it across the national lines or outside the EU, then we will do that. And we will share it with people who can make use of it and who can add it to the cross-correlation they're doing with sensor data that they're also receiving from elsewhere in the world. If, on the other hand, you would like to see some of this data, not just contribute to it, but see it, then again, please contact us. Send us a computer, we'll plug it in. You can write some software, you can see this stuff go by. It is interesting, very hard to deal with because it's coming by so fast. It takes very high clock speeds, a lot of transistors to deal with this. And you can start from our software as you go about building your own analysis. And we have some post-processing that we do using databases and whatnot. So we have some of the traditional web front ends where if you don't want to send us a computer but you want to see what we're seeing, then we can give you a query interface where you could potentially look at it from wherever it is that you're handling your abuse complaints and fraud complaints and whatnot, because it's possible that by adding our data to your data, you can do a better job of keeping the bad guys from using your networks or abusing your customer servers in order to sort of execute their schemes. So in conclusion, we've got two things going on, one being root name service, one being the security services. It's going well so far, and I think that both Flix and ISC are open to broadening the relationship to include other activities in the future as we think of them. And to repeat what I said at the outset, I'm hoping that we can have some discussion here. I've finished deliberately a little bit early, so we can have some questions and some discussion. I would like to hear your feedback. I have come a long way. I'm excited to be here. It's my first trip to Poland. I'm trying to learn what it is that is special and unique about the Polish internet community. So I'm hoping you'll take this time to educate me. Or we can finish early. Thank you very much.